But I'm not quite done with the problem yet because I have to work my way back through two substitutions. First this one, and then this one. So this first substitution isn't so bad to get rid of, to undo, to back substitute, because u was just the sine of theta. And so 1 over u is, I guess a fancy way to write it is the cosecant of theta. Right, 1 over the sine is the cosecant. So I get minus the cosecant of theta plus a constant. Is that a question in the back? Yes, sir?
How do you know to equal, like, x equal to tan?
I'm sorry, my hearing is so bad.
How do you know you should say x equal to tan theta for the beginning of the question?
How did I know this substitution in the first place? The only thing is, so it's because of the 1 plus x squared. And I want to make use of the trig identity in the upper left-hand corner. I'll make you a table in a few minutes that will put all this in a bigger context, and I think it'll help you then. Okay, I'll promise. So what I want to try to talk about right now is how to rewrite a term like this, a trig term like this, back in terms of x. So I want to undo this trig substitution. This is a trig sub. And what I want to do now is try to undo that trig sub. And I'll show you a general method for undoing trig substitutions. This happens quite often. I don't know what the cosecant of theta is, but I do know what the tangent of theta is. So I want to make a relation between them. Okay, so undoing trig subs. So let's go back to where trigonometry always comes from, this right-angled triangle with a theta in the corner. And then these three sides, this one's called the hypotenuse, this one is called the adjacent side, and that one's called the opposite side. Now, let's find out where x lies in this triangle. Let's try to write the sides of this triangle in terms of x. And what I know is x is the tangent of theta. So the tangent of theta, the tangent of this angle, is opposite divided by adjacent. Did you learn SOHCAHTOA? Okay, so it's opposite divided by adjacent is the tangent. So there are different ways to do that, but why not just do it in the simplest way and suppose that the adjacent is 1 and the opposite is x? This is correct now, isn't it? I get the correct value for the tangent of theta by saying that the lengths of those are 1 and x. And that means that the hypotenuse has length 1 plus x squared. Well, here's a triangle. I'm interested in computing the cosecant of theta. Where does that appear in the triangle? Well, let's see. The cosecant of theta is 1 over the sine, and the sine is opposite over hypotenuse, right? So the cosecant is hypotenuse over opposite. Right? And the hypotenuse is the square root of 1 plus x squared, and the opposite is x. And so I've done it. I've undone the trig substitution. I've figured out what this cosecant of theta is in terms of x. And so the final answer is minus the square root of 1 plus x squared over x plus a constant. And there's an answer to the original problem.